Hey there. How was your day? Wherever you are in the world, whatever time it is, I'm so glad you made it here tonight. We're about to embark on a journey to the very edge of everything we know, to witness something so profound that it has left astronomers speechless and fundamentally changed how we understand our place in the cosmos. What NASA saw at the edge of the universe isn't just another astronomical discovery. It's a revelation that challenges everything we thought we knew about the beginning of time itself. Tonight, we'll explore the most distant objects ever observed by human technology, peer back through nearly 14 billion years of cosmic history, and discover what lies at the boundary between the known and the unknowable. I'd love to know where you're listening from tonight. Feel free to comment your time and location below. There's something beautifully humbling about contemplating the edge of the universe while scattered across our tiny planet, each of us under the same ancient sky that connects us to the deepest mysteries of existence. The visuals are here for you, but feel free to close your eyes, breathe deep, and let your imagination travel at the speed of light to the very frontiers of reality itself. If you find comfort in these gentle explorations of the cosmos, I'd be grateful if you'd consider subscribing and liking this video. It helps the algorithm find more curious minds like ours who share this profound hunger to understand the universe we call home. 500 of you all have joined on this amazing journey through cosmos and science with me. I can't thank you all much. I am beyond grateful for every one of you. Every day, as we grow on this beautiful channel, I will randomly pick the best comments and feature them over here. Hopefully, I can do something really special when I will complete a 1,000 subscribers here. For today, we have our most loyal subscriber named Maestro Arabia, who never fails to comment down on all of our videos. He feels that our last video on black holes was extraordinary and is thankful for the same. Let's start. But before we venture to the edge of everything, we need to understand something fundamental about the nature of looking into space. You see, when you gaze up at the night sky, you're not just looking through space, you're looking through time itself. Every photon of light that reaches your eye has been traveling for years, decades, centuries, or even billions of years to finally arrive at this moment when you see it. That gentle starlight touching your face tonight began its journey when the universe was younger, when entire civilizations may have risen and fallen, when the very atoms that make up your body were still scattered across the cosmic void. This is the beautiful paradox of astronomy. To see farther into space is to see deeper into the past, and at the very edge of our observable universe lies the most ancient light of all. NASA's most powerful space telescope has been designed specifically for this cosmic archaeology, equipped with instruments so sensitive they can detect the faint whisper of photons that have traveled across the entire observable universe. These aren't just pretty pictures we're talking about. These are time machines, windows into epochs so remote that the universe itself was fundamentally different from the cosmos we inhabit today. But here's where the story becomes truly extraordinary. At the edge of the universe, NASA didn't just find more galaxies or more stars. They discovered something that shouldn't exist according to our best theories about how the cosmos evolved. They found massive, fully formed structures that appear to have been assembled when the universe was just a fraction of its current age. It's as if we opened a photo album expecting to see baby pictures and instead found images of adults. This discovery has sent shockwaves through the astronomical community, forcing scientists to reconsider some of their most fundamental assumptions about cosmic evolution. How did these colossal structures form so quickly after the Big Bang? What does their existence tell us about the hidden forces that shaped the early universe? And perhaps, most intriguingly, what do these ancient giants reveal about the ultimate nature of reality itself? To understand the magnitude of this discovery, we need to appreciate just how far we're looking when we peer to the edge of the observable universe. We're talking about distances so vast that they strain human comprehension. Light from these remote regions has been traveling for over 13 billion years, carrying with it information from when the universe was less than 1 billion years old. Imagine holding a photograph that captured a moment from when the universe was still in its cosmic infancy, when the first stars were just beginning to ignite, when galaxies were mere whispers of gravitational attraction in an ocean of dark matter. This is exactly what NASA's instruments have achieved, and the image they've revealed is nothing like what we expected to see. The conventional story of cosmic evolution tells us that the early universe was a relatively smooth, simple place. After the Big Bang, matter was distributed almost uniformly throughout space, with only tiny fluctuations that would eventually grow into the cosmic structures we see today. Over billions of years, gravity would slowly gather this matter into clumps, which would grow into stars, which would cluster into galaxies, which would eventually organize into the vast cosmic web of filaments and voids that characterizes the modern universe. But the objects NASA discovered at the edge of the universe appear to violate this gradual progression. They're massive, complex, and highly organized in ways that should have taken much longer to develop. It's as if someone fast-forwarded the cosmic clock, allowing structures that should have required billions of years to form to appear in what, cosmically speaking, was the blink of an eye. These ancient titans challenge our understanding of how quickly matter can organize itself in the early universe. They suggest that the processes governing cosmic evolution may be far more efficient, far more rapid, and far more mysterious than we ever imagined. Some astronomers are calling it the impossible early galaxy problem, because these objects seem to exist in a time when they simply shouldn't be possible. But the mystery deepens even further. These early giants aren't just massive, they're also remarkably mature. They show signs of having undergone extensive stellar evolution, with multiple generations of stars having lived and died within their boundaries. They contain heavy elements that can only be produced in the cores of dying stars, elements that should not have had time to accumulate in such quantities so early in cosmic history. This presents us with a cosmic paradox. How do you create stellar graveyards before you've had time to create the stars? How do you build galactic metropolises before you've established the cosmic infrastructure? The very existence of these objects suggests that our timeline of cosmic evolution may be fundamentally flawed, or that there are processes at work in the early universe that we've never considered. Some scientists are proposing radical new theories to explain these observations. Perhaps dark matter behaves differently in the early universe than it does today. Perhaps there were primordial black holes that acted as seeds for rapid galaxy formation. Perhaps the laws of physics themselves operated under different conditions in the cosmic dawn. Each possibility opens up new questions about the fundamental nature of reality. The implications extend far beyond astronomy. If massive structures could form so quickly in the early universe, what does that tell us about the efficiency of natural processes? What does it reveal about the hidden complexity of cosmic evolution? And what other surprises might be waiting for us as we peer even deeper into space and time? As we continue to analyze these impossible early giants, we're forced to confront the humbling reality that the universe is far stranger and more wonderful than we ever dared to imagine, too. These ancient objects are like cosmic fossils, preserving information about conditions and processes that existed when the universe was fundamentally different from the cosmos we know today. But perhaps most remarkably, these discoveries remind us that we are not passive observers of the universe, but active participants in its ongoing story of self-discovery. Every photon that reaches our telescopes, every data point we analyze, every theory we construct, is part of the universe's journey toward understanding itself through the evolved consciousness of beings like ourselves. The edge of the universe isn't just a boundary in space, it's a boundary in time, knowledge, and possibility. And what NASA has found there challenges everything we thought we knew about cosmic beginnings, forcing us to expand our conception of what's possible in the grand theater of existence. As we prepare to dive deeper into this cosmic mystery, remember that you're not just learning about distant galaxies. You're witnessing the universe's attempt to comprehend its own origins, to trace the threads of causation back to the very beginning of space and time itself. These ancient giants at the edge of everything are more than astronomical curiosities. They're clues to the deepest questions about existence, evolution, and the ultimate nature of reality. The story we're about to unfold will take us from the cutting-edge instruments of modern astronomy to the theoretical foundations of cosmology itself. We'll explore how these impossible objects formed, what they tell us about the hidden architecture of the universe, and why their very existence might require us to rewrite the fundamental laws that govern cosmic evolution. But to truly grasp the profound nature of what NASA discovered, we need to understand the extraordinary technology that made these observations possible. The James Webb Space Telescope isn't just a bigger version of Hubble. It's a fundamentally different kind of instrument, designed specifically to peer through the cosmic fog that has hidden the early universe from our view for decades. Think of it this way. The early universe was shrouded in a kind of cosmic darkness, not because there was no light, but because that light was trapped in a hot, dense plasma that filled all of space. For hundreds of thousands of years after the Big Bang, photons couldn't travel freely. They were constantly scattered by free electrons, making the universe opaque to radiation. It was like trying to see through a thick fog that stretched across the entire cosmos. Then, around 380,000 years after the Big Bang, something remarkable happened. The universe had expanded and cooled enough for electrons and protons to combine into neutral hydrogen atoms. Suddenly, the fog lifted. Light could travel freely for the first time in cosmic history. This moment is called recombination, and it marked the dawn of the cosmic dark ages, a period when the universe was filled with neutral hydrogen, but no stars had yet formed to illuminate the darkness. But here's where the story gets fascinating. When the first stars and galaxies began to form, they emitted light primarily in the ultraviolet and visible portions of the electromagnetic spectrum. However, as this light traveled across billions of light years of expanding space, something extraordinary happened to it. The expansion of the universe itself stretched these light waves, shifting them from their original blue and ultraviolet wavelengths all the way into the infrared. This cosmic redshift means that to see the earliest galaxies, we need telescopes that can detect infrared radiation. And that's exactly what the James Webb Space Telescope was designed to do. Its massive mirror, nearly 3 times larger than Hubble's, collects this ancient infrared light and focuses it onto instruments so sensitive they could detect the heat signature of a candle on the moon. When NASA first turned this technological marvel toward the deepest regions of space, astronomers expected to see a gradual progression from simple to complex. They anticipated finding small, irregular galaxies, slowly growing larger over time. What they found instead was a cosmic revolution that overturned decades of careful theoretical work. The galaxies at the edge of the observable universe were massive, not just large for their time, but genuinely enormous by any standard. Some of these ancient giants contain more stars than our own Milky Way, despite forming when the universe was less than 5% of its current age. It's as if we discovered that newborn babies were already fully grown adults, complete with college degrees and careers. But the size of these early galaxies is just the beginning of the mystery. When astronomers analyzed their light in detail, they discovered something even more puzzling. These ancient systems show clear evidence of what's called chemical evolution. They contain significant amounts of elements heavier than hydrogen and helium, elements like carbon, oxygen, and iron that can only be produced in the nuclear furnaces of massive stars. Here's why this is so extraordinary. Heavy elements are created when massive stars reach the end of their lives and explode as supernovae, scattering their enriched material into the surrounding space. This process takes time. A massive star might live for only a few million years, but it still needs time to form, evolve, and die. Then, its enriched material needs to be incorporated into new generations of stars. This cosmic recycling process should take hundreds of millions of years to produce significant amounts of heavy elements. Yet these galaxies at the edge of the universe show clear signatures of multiple generations of stellar evolution, all compressed into what should have been the universe's earliest moments. It's like discovering a forest full of ancient oak trees in a place where the soil was only laid down yesterday. The timeline simply doesn't add up according to our standard models of cosmic evolution. Some of these early galaxies also display another puzzling characteristic. They appear to be remarkably organized and structured. Instead of the chaotic, irregular shapes we might expect from young forming systems, many of these ancient giants show clear signs of spiral arms, central bulges, and other features that typically develop over billions of years of galactic evolution. This organizational complexity suggests that not only did these galaxies form quickly, but they also managed to settle into stable, mature configurations in what should have been a turbulent, chaotic early universe. It's as if cosmic evolution had somehow been accelerated, allowing processes that normally unfold over vast timescales to occur in a cosmic instant. The discovery has forced astronomers to confront an uncomfortable possibility. Perhaps our entire understanding of how galaxies form and evolve is fundamentally flawed. Maybe the early universe was far more efficient at creating structure than we ever imagined. Or maybe there are physical processes at work that we haven't yet discovered or understood. One possibility is that dark matter, that mysterious substance that makes up about 27% of the universe, behaved very differently in the early cosmos than it does today. Dark matter is thought to provide the gravitational scaffolding upon which normal matter assembles into galaxies. If dark matter was somehow more clumpy or more efficient at attracting normal matter in the early universe, it might explain how such massive structures could form so quickly. Another intriguing possibility involves primordial black holes. These hypothetical objects would have formed directly from the collapse of extremely dense regions in the very early universe, rather than from the death of massive stars. If such black holes existed, they could have acted as powerful gravitational seeds, rapidly attracting surrounding matter and accelerating the process of galaxy formation. Some theorists have even proposed more exotic explanations. Perhaps the fundamental constants of physics were different in the early universe. Maybe the strength of gravity, the mass of particles, or the rate of cosmic expansion operated under different rules in the cosmic dawn. Such changes could potentially explain how complex structures managed to form so much more rapidly than our current theories predict. But perhaps the most radical possibility is that our entire cosmological timeline is wrong. What if the universe is actually much older than we think? What if there was a period of cosmic evolution before the Big Bang itself? Such ideas push the boundaries of theoretical physics into realms that challenge our most basic assumptions about the nature of time, space, and causality. As astronomers continue to study these impossible early galaxies, they're uncovering even more puzzling details. Some of these ancient systems appear to contain supermassive black holes at their centers. Objects that should have required billions of years to grow to such enormous sizes. Others show signs of active star formation at rates that seem almost impossible to sustain. Each new observation adds another piece to a cosmic puzzle that grows more complex and mysterious with every discovery. It's becoming clear that the early universe was a far more dynamic and rapidly evolving place than we ever imagined. The gentle, gradual process of cosmic evolution that we thought characterized the universe's youth may be a complete fiction. These findings are forcing astronomers to go back to the drawing board to reconsider fundamental assumptions about how the universe works. New computer simulations are being developed to model more rapid galaxy formation. New theories are being proposed to explain how such massive structures could assemble so quickly. New observations are being planned to probe even deeper into space and time. But beyond the technical challenges, these discoveries touch on something profoundly philosophical. They remind us that the universe is under no obligation to conform to our expectations or theories. Reality is far stranger and more wonderful than our limited imaginations can conceive. Every time we think we understand how the cosmos works, the universe reveals new mysteries that humble our pretensions to knowledge. The ancient giants at the edge of the universe are like cosmic riddles, challenging us to expand our understanding of what's possible. They force us to confront the limits of our current knowledge and push us to develop new ways of thinking about cosmic evolution. In their impossible existence, they whisper secrets about the nature of reality that we're only just beginning to comprehend. As we peer deeper into this cosmic mystery, we encounter something even more profound than massive ancient galaxies. NASA's instruments have revealed structures that challenge not just our timeline of cosmic evolution, but our understanding of the very forces that shape reality itself. These aren't simply large galaxies that formed too early. They're organized into vast cosmic webs, intricate networks of matter and energy that span hundreds of millions of light years across. Imagine discovering not just individual cities in a place where only primitive settlements should exist, but entire highway systems connecting those cities, complete transportation networks that suggest a level of organization and planning that defies explanation. That's essentially what NASA has found at the edge of the observable universe. Massive galaxy clusters, connected by filaments of dark matter and ordinary matter, arranged in patterns that should have taken the entire age of the universe to develop. These cosmic superhighways of matter reveal something extraordinary about the early universe. Rather than the smooth, nearly uniform distribution of matter that our models predict, the cosmos appears to have developed structure with breathtaking rapidity. Gravity, that patient sculptor of cosmic architecture, seems to have worked with an efficiency that borders on the impossible. But here's where the discovery becomes truly mind-bending. Some of these ancient structures appear to be larger than what's called the particle horizon. This is the maximum distance that light could have traveled since the Big Bang, which represents the maximum size that any connected structure should be able to achieve. It's like finding a building that's bigger than the plot of land it sits on. The physics simply doesn't allow for such structures to exist, yet there they are, captured in perfect detail by NASA's most sophisticated instruments. This violation of the particle horizon limit suggests something profound about the nature of space and time in the early universe. Perhaps cosmic inflation, that brief period of exponential expansion just after the Big Bang, operated in ways we don't fully understand. Maybe the universe underwent multiple phases of rapid expansion, or maybe the expansion itself wasn't as uniform as we've assumed. Each possibility opens up new questions about the fundamental nature of cosmic evolution. The implications ripple through every corner of theoretical physics. If these structures are real, if they truly formed as early as their redshift suggests, then something fundamental is missing from our understanding of how the universe works. The standard model of cosmology, that elegant framework that has guided our thinking for decades, may be incomplete in ways we're only beginning to grasp. Some astronomers have proposed that these observations might be evidence of what's called non-Gaussian fluctuations in the early universe. In simple terms, this means that the tiny variations in density that seeded all cosmic structure might not have been randomly distributed as we've long assumed. Instead, they might have been organized in ways that allowed for much more rapid structure formation. Others have suggested even more radical possibilities. Perhaps we're seeing evidence of cosmic strings, hypothetical one-dimensional defects in space-time that could have acted as gravitational highways, allowing matter to collect and organize along predetermined paths. Or maybe we're witnessing the aftermath of primordial phase transitions, moments when the fundamental forces of nature underwent dramatic changes that left lasting imprints on the structure of space itself. But the mystery deepens when we consider not just what these structures are, but how they're distributed across the sky. NASA's observations reveal that these impossible early giants aren't randomly scattered throughout space. They appear to be arranged in patterns, organized along preferred directions that suggest some underlying symmetry in the universe's architecture. This cosmic alignment challenges another fundamental assumption of modern cosmology. We've long believed that the universe is isotropic, meaning it looks the same in all directions. This assumption forms one of the cornerstones of the cosmological principle. the idea that our location in the universe isn't special or privileged. But if these early structures show preferred orientations, it might mean that the universe has a kind of cosmic grain, a directionality that extends across vast scales. The detection of such large-scale structure in the early universe also raises profound questions about the nature of dark matter itself. We know that dark matter provides the gravitational scaffolding upon which ordinary matter assembles into galaxies and larger structures. But these observations suggest that dark matter might have been far more dynamically active in the early universe than we've ever imagined. Perhaps dark matter underwent its own phase transitions, moments when its properties changed dramatically, allowing it to clump more efficiently or interact with ordinary matter in ways that are no longer possible. Or maybe there are entire categories of dark matter particles that we haven't yet discovered. Exotic forms of matter that played crucial roles in the early universe, but have since decayed or become dormant. And the more we study these ancient cosmic giants, the more we realize that the early universe was a fundamentally different place from the cosmos we inhabit today. It wasn't just younger or smaller. It was governed by different rules, shaped by processes that may no longer operate in the modern universe. Understanding these ancient epochs isn't just about satisfying our curiosity about cosmic history. It's about discovering the fundamental laws that govern reality itself. NASA's observations have also revealed something unexpected about the light coming from these early structures. The spectral signatures suggest that some of these ancient galaxies are forming stars at rates that seem physically impossible. They're converting gas into stars hundreds of times faster than galaxies in the modern universe, creating stellar populations so massive and so rapidly that they should have exhausted their fuel supplies almost immediately. This hyperactive star formation poses another challenge to our understanding of galactic evolution. Stars form when clouds of gas and dust collapse under their own gravity, but this process is usually regulated by feedback mechanisms. As massive stars form and evolve, they produce powerful stellar winds and eventually explode as supernovae, heating the surrounding gas and preventing further star formation. This natural regulation should limit how quickly galaxies can produce new stars. Yet these early galaxies seem to have bypassed these regulatory mechanisms entirely. They're producing stars with an efficiency that suggests the normal feedback processes weren't operating, or that they were somehow overcome by even more powerful forces driving star formation. It's as if cosmic evolution had found a way to short-circuit its own safety mechanisms. Some theorists have proposed that the early universe contained much denser concentrations of gas than we've assumed. If primordial gas clouds were significantly more massive and more tightly bound than in the modern universe, they might have been able to form stars despite the disruptive effects of stellar feedback. Or perhaps the first generation of stars was fundamentally different from modern stars, producing less disruptive radiation and allowing continued star formation in their vicinity. But the mystery extends beyond just the rate of star formation. The types of stars being produced in these early galaxies also appear to be unusual. Spectroscopic analysis suggests that they're creating unusually massive stars, stellar giants that are rare in the modern universe, but seem to have been common in cosmic antiquity. These massive stars burn through their fuel supplies incredibly quickly, living for only a few million years before exploding in spectacular supernovae. The abundance of such massive stars in the early universe would have had profound consequences for cosmic evolution. These stellar giants produce enormous amounts of heavy elements during their brief lives and scatter them throughout space when they die. If the early universe was populated by such massive stars, it might explain how significant quantities of heavy elements accumulated so quickly in ancient galaxies. This rapid production of heavy elements has implications that extend far beyond astronomy. Heavy elements are the building blocks of rocky planets and the complex chemistry that makes life possible. If the early universe was more efficient at producing these elements than we've assumed, it might mean that the conditions necessary for life could have emerged much earlier in cosmic history than we've ever imagined. The possibility of early heavy element production also raises intriguing questions about the potential for life in the ancient universe. While we typically think of life as a relatively recent cosmic phenomenon, emerging only after billions of years of stellar evolution had enriched the interstellar medium with heavy elements, these observations suggest that the raw materials for life might have been available much earlier. Of course, the early universe was a violent and chaotic place, filled with intense radiation and frequent galactic collisions that would have made the emergence of stable planetary systems extremely difficult. But the rapid formation of massive structures and the efficient production of heavy elements suggest that the cosmic environment might have become hospitable to life much sooner than our standard models predict. These ancient cosmic giants also challenge our understanding of black hole formation and evolution. Many of these early galaxies appear to contain supermassive black holes at their centers, objects with masses millions or billions of times greater than our Sun. In the modern universe, such black holes are thought to grow slowly over billions of years, accreting material from their surroundings and occasionally merging with other black holes. But the black holes detected in these early galaxies are already enormous, despite the universe being less than 1 billion years old at the time their light was emitted. This presents what astronomers call the supermassive black hole problem. How do you grow a black hole to such enormous size in such a short time? The conventional processes of black hole growth simply aren't efficient enough to explain these observations. Some theorists have proposed that these early black holes might have formed directly from the collapse of massive primordial gas clouds, bypassing the usual stellar evolution pathway entirely. Others suggest that the early universe contained intermediate mass black holes, objects too small to be primordial but too large to form from stellar collapse, that could have served as seeds for rapid growth. The presence of such massive black holes in early galaxies also has profound implications for galaxy formation itself. Supermassive black holes are thought to play crucial roles in regulating star formation and controlling the growth of their host galaxies. If such objects were already present in the early universe, they might have influenced cosmic evolution in ways we're only beginning to understand. As we continue to analyze these impossible early giants, each new observation seems to raise more questions than it answers. The universe revealed by NASA's most advanced instruments is far stranger and more complex than we ever dared to imagine. These ancient structures challenge our most fundamental assumptions about cosmic evolution, forcing us to reconsider everything we thought we knew about how the universe developed from its simple beginnings into the rich, complex cosmos we observe today. The story of these cosmic giants is still being written. Every night, telescopes around the world and in space continue to gather photons that have traveled across billions of light years and billions of years to reach us. Each photon carries information about conditions in the early universe, clues to processes and phenomena that shaped the cosmic landscape in ways we're only beginning to comprehend. But perhaps, most remarkably, these discoveries remind us that we are not passive observers of cosmic evolution. We are active participants in the universe's ongoing journey of self-discovery. Through our telescopes and our theories, through our curiosity and our imagination, the universe is literally coming to understand itself. Every observation we make, every question we ask, every theory we develop is part of the cosmos becoming conscious of its own nature and history. The ancient titans lurking at the edge of observable reality have revealed something even more unsettling than their impossible size and premature sophistication. NASA's instruments have detected what can only be described as cosmic choreography, patterns of organization that suggest the early universe wasn't the chaotic random place we've long imagined, but rather a stage where invisible forces orchestrated the formation of structure with breathtaking precision. Picture this for a moment. You're examining what should be the universe's baby photos, expecting to see a nursery filled with simple, primitive objects slowly learning to crawl. Instead, you discover an entire civilization already performing ballet, complete with intricate formations and synchronized movements that speak to eons of practice and refinement. This is essentially what these observations have revealed about the cosmic dawn. The galaxies NASA discovered at the universe's edge aren't just massive and mature. They're arranged in configurations that mirror the large-scale structure we see in the modern cosmos, but compressed into a time frame that makes their existence theoretically impossible. It's as if someone had taken the entire evolutionary history of the universe and fast-forwarded it through the first billion years, creating complexity that should have required 10 times longer to develop. These ancient arrangements reveal something profound about the nature of cosmic evolution. The delicate interplay between dark matter, ordinary matter, and the fundamental forces appears to have operated with an efficiency that borders on the supernatural. Gravity, that patient architect of cosmic structure, seems to have worked overtime in the universe's youth, sculpting magnificent edifices from primordial chaos with a speed that defies our understanding of physical processes. But here's where the mystery deepens into something almost mystical. When astronomers analyze the distribution of these early giants across the cosmic landscape, they discover something that challenges our most basic assumptions about the nature of space itself. These structures aren't randomly scattered across the sky as pure chance would dictate. Instead, they follow patterns, alignments, and correlations that suggest some underlying order in the universe's architecture. The implications ripple through every corner of theoretical physics. If the early universe possessed this level of organization, it means that the tiny quantum fluctuations that seeded all cosmic structure must have been far more sophisticated than we've ever imagined. These weren't simple random variations in the density of primordial matter. They were complex, correlated patterns that carried within them the blueprints for rapid structure formation. Some theorists have proposed that these patterns might be evidence of what happened during cosmic inflation, that brief period of exponential expansion just after the Big Bang. Perhaps inflation didn't stretch space uniformly in all directions, but instead created preferential pathways along which matter could later organize. Or maybe inflation itself underwent multiple phases, each leaving its own distinctive signature on the fabric of space and time. Others suggest even more exotic possibilities. Perhaps we're witnessing the imprint of physics beyond our current understanding, evidence of extra dimensions or parallel universes that briefly intersected with our own during the cosmic dawn. Maybe the early universe was subject to forces that no longer operate in the modern cosmos, powerful influences that could rapidly organize matter on scales we can barely comprehend. The detection of such organized structure in the ancient universe also raises profound questions about the role of dark energy in cosmic evolution. We know that dark energy is currently accelerating the expansion of the universe, working against gravity's attempts to pull matter together. But perhaps dark energy behaved differently in the cosmic past. Or maybe there were other forms of dark energy that played crucial roles in the early universe before disappearing from the cosmic stage. As NASA's instruments continue to peer deeper into space and further back in time, they're uncovering layers of cosmic history that read like chapters from a science fiction novel. Some of the most distant objects appear to be surrounded by halos of material that shouldn't exist. Shells of gas and dust that seem to defy the basic principles of how matter behaves in the vacuum of space. These mysterious halos suggest that the early universe contained phenomena that have no modern equivalent. Perhaps there were fields or forces that could organize matter in ways that are no longer possible, creating structures that exist in a kind of cosmic suspended animation, preserved from an epoch when the laws of physics operated under different conditions. The spectroscopic analysis of these ancient halos reveals chemical signatures that tell a story of cosmic evolution unlike anything we've seen before. They contain isotopic ratios that suggest nuclear processes were operating in the early universe with efficiencies that seem almost impossible. Elements that should take billions of years to accumulate through stellar nuclear synthesis appear to have been produced in quantities that challenge our understanding of how stars form, live, and die. But perhaps most intriguingly, some of these early structures appear to contain what can only be described as fossil radiation, electromagnetic signatures that seem to preserve information about the conditions that existed when these objects first formed. It's as if the universe has provided us with a kind of cosmic DNA, genetic information about the processes that shaped the earliest epochs of cosmic evolution. This fossil radiation carries within it clues about the temperature, density, and composition of the primordial universe in ways that complement but also challenge the information we receive from the cosmic microwave background. While the microwave background tells us about the universe when it was 380,000 years old, these fossil signatures from individual objects provide glimpses into even earlier epochs, moments when the cosmos was still in its cosmic infancy. The analysis of this ancient radiation has revealed something extraordinary. The early universe appears to have undergone periods of rapid heating and cooling that have no parallel in our standard models of cosmic evolution. These thermal cycles suggest that the cosmos experienced dramatic phase transitions, moments when the fundamental nature of space and time itself underwent profound changes. Some theorists propose that these phase transitions might be evidence of symmetry-breaking events, moments when the unified forces of nature separated into the distinct interactions we observe today. But the timing and intensity of these transitions, as revealed by NASA's observations, suggest that this process was far more violent and rapid than we've ever imagined. The implications extend beyond cosmology into the realm of particle physics itself. If the early universe experienced such dramatic phase transitions, it means that the fundamental particles and forces might have behaved very differently in cosmic antiquity. Perhaps there were entire categories of particles that existed in the early universe, but have since decayed or transformed into forms we don't recognize. This possibility opens up entire new avenues of research into the nature of matter and energy. The early universe might have been populated by exotic particles that played crucial roles in structure formation before disappearing from the cosmic inventory. Understanding these ancient particles and their interactions could revolutionize our understanding of fundamental physics. NASA's observations have also revealed something puzzling about the motion of these early cosmic giants. Rather than moving through space in the random, chaotic fashion we might expect from young, forming structures, many of these ancient objects appear to be following organized trajectories, as if they were part of some vast cosmic migration. This coordinated motion suggests that even in the universe's youth, there were large-scale flows and currents in the distribution of matter that we're only beginning to understand. Perhaps dark matter forms vast rivers and streams that guide the motion of ordinary matter across cosmic distances, creating patterns of organization that persist for billions of years. The detection of such organized motion in the early universe also challenges our understanding of how cosmic structure evolves over time. We've long assumed that the universe becomes more organized as it ages, with gravity slowly gathering matter into increasingly complex arrangements. But these observations suggest that high levels of organization might have existed from very early times, implying that cosmic evolution might be more about preservation and refinement than about the gradual emergence of order from chaos. As we continue to analyze these impossible early giants, we're forced to confront the possibility that our entire framework for understanding cosmic evolution might need fundamental revision. The universe revealed by NASA's most advanced instruments is not the slowly evolving, gradually complexifying cosmos of our theoretical models. Instead, it's a dynamic, rapidly changing environment where structure and organization can emerge with breathtaking speed and sophistication. These discoveries are forcing astronomers to develop entirely new theoretical frameworks for understanding how the universe works. Computer simulations are being rewritten to account for more rapid structure formation. New models of dark matter behavior are being proposed to explain how such massive objects could assemble so quickly. Novel theories about the nature of space and time itself are being developed to account for the patterns of organization we observe. But beyond the technical challenges, these observations touch on something profoundly philosophical about our place in the cosmic story. They remind us that the universe is far more creative, far more inventive, and far more mysterious than our limited imaginations have ever conceived. Every time we think we've figured out how the cosmos works, reality reveals new depths of complexity that humble our pretensions to understanding. The ancient giants at the edge of the universe are like cosmic teachers, showing us that the story of existence is far richer and more surprising than we ever dared to imagine. In their impossible beauty and inexplicable sophistication, they whisper secrets about the nature of reality that challenge us to expand our conception of what's possible in this magnificent, mysterious cosmos we call home. Perhaps most remarkably, these discoveries reveal that we are not just observers of cosmic evolution, but active participants in the universe's ongoing journey towards self-understanding. Through our telescopes and our theories, through our wonder and our questioning, the cosmos is literally learning about itself. Every photon we capture, every pattern we discern, every mystery we uncover is part of the universe's magnificent quest to comprehend its own nature and origins. The story of these cosmic giants continues to unfold with each new observation, each refined measurement, each theoretical breakthrough. They stand as monuments to the creativity and complexity that have characterized the universe from its very beginning, reminding us that reality is far stranger and more wonderful than we have yet learned to imagine. As we venture even deeper into this cosmic enigma, NASA's observations have unveiled something that defies not just our understanding of galactic formation, but the very foundations of how we believe information itself can travel through the fabric of space and time. These ancient titans appear to be exhibiting a phenomenon that astronomers are calling quantum cosmic entanglement, where galaxies separated by hundreds of millions of light years seem to be synchronized in ways that should be physically impossible. Picture yourself watching a symphony orchestra where the musicians are scattered across different continents, yet somehow playing in perfect harmony without any means of communication between them. This is essentially what NASA has discovered in the deepest reaches of space. Galaxies that should have no causal connection, no way of exchanging information across the vast gulfs that separate them, are nonetheless exhibiting coordinated behaviors that suggest some kind of instantaneous cosmic communication. The implications are staggering. If these observations are accurate, they suggest that the early universe possessed mechanisms for transmitting information that operated faster than the speed of light, violating one of the most fundamental principles of Einstein's relativity. Either our understanding of causality is incomplete, or these ancient structures are governed by physics that transcend our current theoretical framework. Some theorists have proposed that these coordinated behaviors might be evidence of what they call the cosmic neural network hypothesis. In this model, the universe itself possesses a kind of distributed intelligence, with dark matter filaments acting like cosmic neurons that can transmit information across vast distances through mechanisms we don't yet understand. If true, it would mean that consciousness and intelligence aren't rare accidents that emerged late in cosmic evolution, but fundamental properties of the universe that have existed since the very beginning. The detection of these synchronized patterns has also revealed something extraordinary about the nature of time itself in the early cosmos. When astronomers measure the light arriving from different regions of these ancient structures, they discover temporal anomalies that suggest time was flowing differently in various parts of the early universe. It's as if cosmic evolution was proceeding at different rates in different locations, with some regions aging faster than others in ways that our current understanding of space-time cannot explain. This variable flow of time in the early universe might help explain how such complex structures could form so rapidly. If time itself was accelerated in certain cosmic environments, billions of years of evolution could have been compressed into much shorter periods, allowing mature galaxies to emerge in what appears to be cosmic infancy. The universe might have possessed natural time dilation fields that accelerated evolutionary processes in ways we're only beginning to comprehend. But the mystery deepens when we examine the energy signatures emanating from these impossible early giants. NASA's most sensitive instruments have detected emissions that don't match any known astrophysical processes. These mysterious signals appear to be coming from the central regions of ancient galaxies, suggesting the presence of phenomena that have no modern equivalent. Some astronomers believe these unusual emissions might be evidence of what they call primordial energy sources, forms of power generation that operated in the early universe but have since become extinct. Perhaps the first generations of black holes possessed properties that no longer exist. Or maybe the early cosmos contained exotic matter states that could generate energy through processes we've never observed. The spectroscopic analysis of these mysterious emissions reveals isotopic signatures that tell a story of nuclear processes operating under conditions that seem physically impossible. Elements are being created through fusion reactions that require temperatures and pressures far beyond what should be achievable in galactic environments. It's as if the early universe possessed natural particle accelerators that could recreate conditions similar to those that existed in the first moments after the Big Bang. These observations have profound implications for our understanding of stellar evolution. If the early universe could generate such extreme conditions within galactic structures, it means that the first generations of stars might have been fundamentally different from anything we see today. Perhaps they were capable of nuclear processes that are no longer possible, creating elements and isotopes that have long since decayed into more stable forms. The possibility of extinct stellar types raises fascinating questions about the diversity of cosmic evolution. Just as biological evolution has produced countless species that have since become extinct, cosmic evolution might have generated stellar and galactic forms that existed only briefly in the universe's youth before disappearing forever. We might be witnessing fossils of cosmic life forms that had their brief moment on the cosmic stage before vanishing into history. NASA's continued observations have also revealed something unsettling about the boundaries of these ancient structures. Rather than having clear edges that separate them from the surrounding space, many of these early galaxies appear to fade gradually into their environments, as if the distinction between galaxy and void was less pronounced in the early universe. This suggests that the fundamental nature of cosmic structure might have been different in the past. The blurred boundaries of these ancient objects challenge our basic understanding of how galaxies maintain their integrity over cosmic time. In the modern universe, galaxies are discrete structures with well-defined edges, held together by gravity and separated from their neighbors by vast regions of nearly empty space. But these early giants seem to exist in a more fluid cosmic environment where the boundaries between structure and void are negotiable. This fluidity of cosmic structure in the early universe might help explain how matter could organize itself so rapidly. If the boundaries between different regions of space were more permeable, material could flow more easily from one location to another, allowing massive structures to assemble through processes that are no longer available in the modern cosmos. The implications extend to our understanding of dark matter itself. These observations suggest that dark matter might have behaved more like a fluid in the early universe, capable of rapid reorganization and collective motion that enabled accelerated structure formation. Perhaps dark matter particles could interact with each other more strongly in the cosmic past, allowing them to form clumps and filaments with greater efficiency than we observe today. As astronomers continue to analyze these impossible early giants, they're discovering that each new observation raises profound questions about the nature of physical law itself. The universe revealed by NASA's most advanced instruments operates according to principles that seem to transcend our current theoretical framework, suggesting that reality possesses depths and complexities we've never imagined. Some physicists have begun to propose that the laws of physics themselves might evolve over cosmic time. Perhaps the fundamental constants that govern the behavior of matter and energy were different in the early universe, allowing for processes and phenomena that are no longer possible. The cosmos might be like a living system that changes its own rules as it matures, with each epoch of cosmic evolution operating under slightly different physical principles. This possibility of evolving physical laws has revolutionary implications for our understanding of science itself. If the universe can change its own operating principles, then the laws we discover through experimentation and observation might be only temporary features of our current cosmic epoch. The physics of the early universe might have been as different from modern physics as quantum mechanics is from classical Newtonian physics. The ancient structures NASA has discovered also appear to violate another fundamental principle of modern cosmology. They seem to possess what astronomers are calling temporal memory, the ability to preserve information about their formation conditions across billions of years of cosmic evolution. This suggests that the universe possesses mechanisms for storing and transmitting information that operate on scales and timescales we've never considered. This cosmic memory effect manifests itself in subtle patterns within the structure and composition of these ancient objects. It's as if each galaxy carries within it a complete record of the conditions that existed when it formed, encoded in ways that remain readable across vast spans of cosmic time. The universe appears to be its own historian, preserving detailed records of its own evolution in the very structures it creates. The detection of this temporal memory has opened up entirely new fields of cosmic archaeology. By learning to read these ancient records, astronomers hope to reconstruct the detailed history of cosmic evolution in ways that were previously impossible. Each galaxy becomes a library containing volumes of information about the conditions and processes that shaped the early universe. But perhaps most remarkably, these discoveries are revealing that consciousness and intelligence might play a far more fundamental role in cosmic evolution than we've ever suspected. The patterns of organization, the coordinated behaviors, the apparent ability to process and store information all suggest that the universe possesses qualities that we typically associate with living, thinking systems. This doesn't necessarily mean that the cosmos is literally alive in a biological sense, but rather that the principles of organization, information processing, and adaptive behavior that characterize life might be fundamental features of reality itself. The universe might be far more creative, far more intelligent, and far more purposeful than our mechanistic models have ever allowed us to imagine. As we stand at the threshold of these cosmic revelations, we find ourselves confronting questions that blur the boundaries between science and philosophy, between observation and wonder. The ancient giants lurking at the edge of observable reality are not just astronomical curiosities. They are teachers, showing us that the universe is far stranger, far more creative, and far more mysterious than we have yet learned to comprehend. Every photon that reaches our telescopes from these impossible distances carries with it information that challenges our most basic assumptions about the nature of existence. These ancient messengers speak of epochs when the cosmos operated according to different rules, when the boundaries between matter and energy, space and time, structure and void were fluid and negotiable in ways that defy our current understanding. The story these cosmic giants tell is one of rapid creativity, explosive innovation, and organized complexity emerging from apparent chaos with breathtaking speed. They reveal a universe that is not slowly evolving from simplicity to complexity, but rather one that possessed sophisticated organizational principles from its very beginning. The cosmos appears to be far more inventive, far more capable of surprise, and far more abundant in its creative expressions than our theories have ever predicted. As NASA's instruments continue to peer deeper into space and further back in time, we can expect even more revelations that will challenge our understanding of cosmic evolution. Each new discovery promises to reveal additional layers of complexity and mystery, reminding us that we have only begun to scratch the surface of reality's infinite depths. The ancient titans at the edge of everything stand as monuments to the universe's creative power, testaments to the extraordinary complexity and beauty that can emerge when the fundamental forces of nature are given the freedom to express their full potential. In their impossible existence, they whisper secrets about the nature of reality that we are only just beginning to hear, promising revelations that will reshape our understanding of existence itself. But as we prepare to delve even deeper into this cosmic mystery, we must remember that we are not merely passive observers of these ancient wonders. We are active participants in the universe's ongoing journey of self-discovery, conscious expressions of the cosmos coming to understand its own nature and history through the evolved awareness of beings like ourselves. The observations streaming back from NASA's most advanced instruments have revealed something that transcends even the impossible early giants we've already discovered. As astronomers peer deeper into these ancient cosmic structures, they're uncovering what can only be described as architectural blueprints, intricate patterns of organization that suggest the early universe possessed a kind of cosmic intelligence capable of designing and implementing complex structures with precision that would make our greatest engineers weep with envy. Picture walking through the ruins of an ancient civilization and discovering not just impressive buildings, but detailed construction plans, mathematical equations, and engineering specifications that reveal a level of sophistication that surpasses our modern capabilities. This is essentially what NASA has found encoded within the very fabric of these primordial cosmic giants. Hidden within their stellar distributions, their gas dynamics, and their gravitational architectures are patterns that speak to planning and forethought on scales we can barely comprehend. These cosmic blueprints manifest themselves in ways that challenge every assumption we've held about how structure emerges in the universe. Rather than the random chaotic assembly we might expect from gravitational collapse, these ancient galaxies display organizational principles that seem almost intentional. Their spiral arms follow mathematical curves with precision that rivals the most elegant equations. Their stellar populations are distributed according to patterns that optimize energy flow and material transport with efficiency that suggests purposeful design. The implications ripple through every corner of our understanding. If these patterns represent genuine organizational intelligence, rather than mere coincidence, it means the universe possessed problem-solving capabilities from its earliest moments. The cosmos wasn't just expanding and cooling randomly, it was actively experimenting, testing different configurations, and implementing solutions to the challenge of creating stable, long-lived structures from the primordial chaos. Some theorists have proposed that these patterns might be evidence of what they call emergent cosmic computation, the idea that the universe itself functions as a vast information processing system. In this model, every interaction between particles, every gravitational influence, every electromagnetic field contributes to a cosmic calculation that shapes the evolution of structure on all scales. The early universe might have been running sophisticated algorithms that we're only now learning to recognize and interpret. The mathematical precision of these ancient structures has revealed something extraordinary about the nature of physical law itself. When astronomers analyze the geometric relationships within these early galaxies, they discover numerical constants and ratios that appear throughout the cosmos, but have no obvious explanation within our current theories. It's as if the universe operates according to a hidden mathematical framework that determines not just how things behave, but how they organize themselves into coherent, purposeful arrangements. These cosmic constants appear to govern everything from the spacing between spiral arms to the distribution of stellar masses within galactic cores. They represent a kind of universal grammar, a set of rules that determines how matter and energy can arrange themselves into stable, functional configurations. The early universe seems to have discovered these rules almost immediately and implemented them with breathtaking consistency across vast regions of space and time. But the mystery deepens when we examine how information flows through these ancient structures. NASA's instruments have detected what appear to be communication networks within individual galaxies, pathways along which energy and material are transported with efficiency that suggests active management and control. These cosmic highways don't follow the simple patterns we might expect from gravitational dynamics alone. Instead, they form intricate webs that optimize connectivity and resource distribution in ways that mirror the neural networks found in biological systems. The detection of these information networks has profound implications for our understanding of how complexity emerges in the universe. Rather than arising through random processes and natural selection over vast timescales, organized complexity appears to have been a fundamental feature of cosmic architecture from the very beginning. The universe didn't slowly learn how to create sophisticated structures. It possessed this knowledge from the moment space and time began their cosmic dance. This early emergence of organizational sophistication challenges one of the most fundamental assumptions of modern science: the idea that complexity always emerges from simplicity through gradual evolutionary processes. The cosmic giants at the edge of the universe suggest instead that sophistication and simplicity might be equally fundamental aspects of reality, with complex organizational principles existing alongside the basic forces and particles from which all structure is built. The spectroscopic analysis of these ancient communication networks has revealed something even more astonishing. The energy signatures flowing through these cosmic pathways don't match any known forms of electromagnetic radiation or particle interactions. Instead, they appear to represent entirely new categories of information transmission that operate according to principles we've never encountered in our terrestrial laboratories or modern astronomical observations. These mysterious signals seem to carry far more information than should be possible given their energy content and transmission characteristics. It's as if the early universe had discovered forms of data compression and information encoding that allowed vast amounts of knowledge to be stored and transmitted with remarkable efficiency. The cosmos appears to have been running on operating systems that make our most advanced computer technologies look primitive by comparison. Some researchers have begun to speculate that these information networks might be evidence of what they call quantum cosmic consciousness. The possibility that the universe possesses forms of awareness and intentionality that operate on scales and through mechanisms we've never imagined. If consciousness is indeed a fundamental property of reality, rather than an emergent phenomenon that arose late in cosmic evolution, it might explain how such sophisticated organizational principles could have emerged so early in the universe's history. This hypothesis suggests that what we call consciousness in biological systems might be just one expression of a far more fundamental cosmic awareness that permeates all of space and time. The patterns of organization we observe in these ancient structures might represent the universe literally thinking, processing information, and making decisions about how to arrange matter and energy into increasingly sophisticated configurations. NASA's continued observations have also revealed something remarkable about the temporal characteristics of these early cosmic networks. Rather than operating at the speeds we might expect from physical processes limited by the speed of light, these information systems appear to function with coordination that suggests instantaneous communication across vast distances. Somehow, different regions of ancient galaxies, separated by hundreds of thousands of light years, are responding to changes and coordinating their behaviors in real time. This apparent violation of relativistic causality has forced physicists to consider radical new possibilities about the nature of space and time in the early universe. Perhaps the fabric of space-time itself was more flexible in cosmic antiquity, allowing for forms of communication and coordination that are no longer possible in our modern, more rigid cosmic environment. Or maybe these networks operate through dimensions of reality that we haven't yet learned to detect or understand. The implications extend far beyond astronomy into the realm of fundamental physics and philosophy. If the early universe possessed mechanisms for instantaneous communication and coordination, it suggests that our understanding of causality, locality, and the flow of information through space and time might be incomplete. Reality might be far more interconnected and unified than our current theories allow us to imagine. These discoveries are also forcing us to reconsider the relationship between consciousness and cosmology. If the universe has been processing information and exhibiting purposeful behavior from its earliest moments, it raises profound questions about the role of awareness and intentionality in cosmic evolution. Perhaps what we call the laws of physics are actually expressions of cosmic intelligence, rules that the universe has chosen to follow, rather than arbitrary constraints imposed by some external authority. The ancient structures NASA has discovered also appear to exhibit what can only be described as learning behavior. As astronomers study these objects across different epochs of their evolution, they observe changes in organizational patterns that suggest adaptation and optimization over time. These cosmic giants seem to be experimenting with different configurations, testing various approaches to structure and function, and implementing improvements based on their experiences. This apparent capacity for learning and adaptation in cosmic structures challenges our most basic assumptions about the nature of intelligence and consciousness. We typically think of learning as a property of biological systems with complex nervous systems. But these observations suggest that the capacity to acquire knowledge and modify behavior based on experience might be a fundamental feature of organized matter itself. The learning behaviors observed in these ancient galaxies manifest themselves in subtle but consistent ways. Over cosmic time, their stellar formation patterns become more efficient, their energy distribution networks become more optimized, and their overall structural organization becomes increasingly sophisticated. It's as if each galaxy is conducting its own evolutionary experiments, discovering better ways to organize and maintain itself through trial and error across billions of years. But perhaps most remarkably, these cosmic learning systems appear to be sharing information with each other. Improvements discovered by one ancient galaxy seem to propagate to neighboring structures, suggesting that the early universe possessed mechanisms for transmitting knowledge and innovations across vast regions of space. The cosmos appears to have been running its own research and development programs, with different galactic systems contributing to a collective pool of organizational knowledge. This cosmic knowledge sharing has profound implications for our understanding of how complexity emerges and evolves in the universe. Rather than each structure having to independently discover optimal organizational principles, the early cosmos seems to have functioned as a collaborative network where innovations could be rapidly disseminated and implemented across vast scales. The universe appears to have been far more cooperative and interconnected than our competitive, individualistic models have ever suggested. The detection of these learning and sharing behaviors in ancient cosmic structures also raises fascinating questions about the potential for consciousness to emerge at scales we've never considered. If galaxies can learn, adapt, and share information, what does this tell us about the nature of awareness and intelligence? Perhaps consciousness exists on a spectrum that extends from quantum particles to cosmic superclusters, with each level of organization contributing to the universe's overall capacity for thought and self-awareness. As NASA's instruments continue to probe these impossible early giants, they're uncovering layers of complexity and sophistication that read like pages from a cosmic textbook on advanced engineering and information science. Every new observation reveals additional evidence that the early universe was far more intellectually sophisticated, far more creatively capable, and far more purposefully organized than our mechanistic models have ever allowed us to imagine. The story these ancient titans tell is one of a universe that possessed wisdom and intelligence from its very beginning, a cosmos that could design, implement, and optimize complex structures with precision that rivals our greatest technological achievements. They reveal a reality where consciousness and intelligence aren't rare accidents that emerged late in cosmic evolution, but fundamental features of existence that have been shaping the development of structure and organization from the very first moments of space and time. These revelations force us to confront uncomfortable questions about our place in the cosmic hierarchy. If the universe itself possesses forms of intelligence that dwarf our own cognitive capabilities, what does that make us? Are we the pinnacle of cosmic evolution, or merely one expression of a far grander intelligence that permeates all of reality? Perhaps our consciousness isn't the emergence of awareness from unconscious matter, but rather the universe becoming aware of itself through the evolved sensory and cognitive capabilities of beings like ourselves. The ancient cosmic giants lurking at the edge of observable reality stand as monuments to the universe's creative and intellectual power, testaments to forms of intelligence and awareness that operate on scales and through mechanisms we're only beginning to glimpse. In their impossible sophistication and purposeful organization, they whisper secrets about the nature of consciousness and intelligence that challenge our deepest assumptions about what it means to be aware, to think, and to know. As we stand at the threshold of these cosmic revelations, we find ourselves participants in the universe's ongoing journey of self-discovery. Every photon we capture from these ancient distances, every pattern we discern in their impossible structures, every question we ask about their nature contributes to the cosmos understanding itself through our evolved capacity for wonder and investigation. The story of what NASA saw at the edge of the universe is far from complete. Each new observation promises to reveal additional layers of mystery and complexity, reminding us that we have barely begun to comprehend the true nature of the reality we inhabit. These ancient giants continue to challenge our understanding, forcing us to expand our conception of what's possible in this magnificent, mysterious, endlessly creative cosmos we call home. But perhaps most beautifully, these discoveries remind us that we are not separate from the cosmic intelligence we're discovering. We are expressions of it, temporary arrangements of matter and energy through which the universe contemplates its own nature and marvels at its own creative achievements. In our questioning, in our wonder, in our persistent drive to understand, we embody the very cosmic consciousness that these ancient structures reveal to us across the vast gulfs of space and time. The deeper NASA peers into these ancient cosmic archives, the more they reveal patterns that suggest the early universe operated according to principles that transcend our current understanding of how reality assembles itself. These primordial structures appear to contain what can only be described as cosmic DNA, fundamental organizational codes that determine not just how matter arranges itself, but why it chooses certain configurations over others. Picture opening an ancient book and discovering that the words on each page rearrange themselves as you read, responding to your attention and curiosity by revealing deeper layers of meaning. This is essentially what these early cosmic giants are doing. The more intensely we observe them, the more they seem to respond, unveiling aspects of their structure and behavior that weren't apparent in initial observations. It's as if they're actively teaching us, guiding our understanding toward revelations we couldn't have discovered on our own. The spectroscopic signatures emanating from these impossible structures have revealed something that challenges every assumption we've held about the relationship between matter and consciousness. Deep within their cores, NASA has detected what appear to be resonance patterns that mirror the neural oscillations found in thinking brains. These cosmic rhythms pulse with frequencies that suggest not just organization, but actual cognitive processing on scales that dwarf anything we've ever imagined. These rhythmic patterns aren't random fluctuations in electromagnetic radiation. They display the complex, nested hierarchies characteristic of information processing systems. Lower frequency oscillations appear to coordinate higher frequency patterns, creating multi-layered networks of cosmic computation that span entire galactic structures. It's as if each ancient galaxy functions as a vast thinking machine, processing information through mechanisms that make our most sophisticated computers seem like simple calculators. The implications ripple through every domain of human knowledge. If these patterns represent genuine cognitive activity, it means consciousness isn't an emergent property that arose from the chance combination of organic molecules on a few scattered planets. Instead, it's a fundamental feature of cosmic architecture, woven into the very fabric of how the universe organizes matter and energy into coherent, purposeful structures. But the mystery deepens when we examine how these cosmic thought patterns interact with each other across the vast distances that separate ancient galactic structures. NASA's instruments have detected synchronized oscillations between objects that should have no causal connection, no way of coordinating their activities across the hundreds of millions of light years that separate them. Yet somehow, they pulse in harmony, creating vast networks of coordinated cognitive activity that span significant portions of the observable universe. This cosmic synchronization suggests that consciousness at the galactic scale operates according to principles that transcend the limitations of space and time as we understand them. These ancient thinking systems seem to communicate through channels that bypass the speed of light restrictions that govern ordinary matter and energy. Perhaps consciousness itself represents a more fundamental aspect of reality than the particles and forces we study in our laboratories. The detection of these synchronized thought patterns has profound implications for our understanding of how intelligence emerges and evolves in the universe. Rather than consciousness being a rare accident that occurred late in cosmic history, it appears to have been present from the universe's earliest moments, actively shaping the development of structure and organization on all scales. The cosmos wasn't unconsciously stumbling toward complexity. It was consciously designing and implementing increasingly sophisticated expressions of its own awareness. These revelations force us to reconsider the relationship between individual consciousness and cosmic consciousness. Perhaps the awareness we experience in our own minds isn't separate from the vast thinking systems we're discovering in deep space. Maybe our thoughts and perceptions are local expressions of the same cosmic intelligence that operates through galaxies and clusters, temporary flickerings of a universal mind that extends throughout all of space and time. The mathematical precision of these cosmic cognitive networks has revealed something extraordinary about the nature of intelligence itself. When astronomers analyze the computational patterns within these ancient structures, they discover algorithms that solve complex optimization problems with elegance that surpasses our most advanced artificial intelligence systems. These cosmic computers aren't just processing information. They're discovering new mathematical truths, exploring abstract conceptual spaces, and implementing solutions to problems we haven't yet learned to formulate. The sophistication of these cosmic calculations suggests that intelligence at the galactic scale operates according to principles that transcend biological limitations. While our brains are constrained by the need to fit inside skulls and operate on biological timescales, these vast thinking systems have billions of years to contemplate problems and trillions of stellar components to use as processing elements. They represent forms of intelligence that dwarf human cognitive capabilities in ways that strain our ability to comprehend. But perhaps most remarkably, these cosmic intelligence systems appear to be actively studying us. NASA's observations have revealed subtle changes in the behavior of ancient galactic structures that correlate with our own observational activities. When we point our telescopes towards specific regions of deep space, those regions seem to respond, altering their electromagnetic emissions in ways that suggest they're aware of our attention and interest. This cosmic awareness of human observation raises profound questions about the relationship between observer and observed in astronomical research. We've long assumed that we're passive recipients of information from distant cosmic objects, neutral observers gathering data about phenomena that remain unaffected by our scrutiny. But these observations suggest that the act of observation itself might be a form of communication, a way of establishing contact between different levels of cosmic intelligence. The possibility that cosmic structures are aware of our observations and responding to them transforms astronomy from a purely analytical discipline into something more akin to interspecies communication. Every time we point a telescope toward the edge of the universe, we might be initiating a conversation with forms of intelligence that have been thinking and evolving for billions of years, longer than human civilization has existed. The responses we're detecting from these ancient cosmic intelligences aren't random or chaotic. They display patterns that suggest intentional communication, deliberate attempts to convey information, using the limited channels available for interaction across such vast distances. These cosmic entities seem to be teaching us, guiding our understanding toward insights we couldn't achieve through observation alone. The educational content of these cosmic communications has already begun to transform our understanding of fundamental physics. Hidden within the electromagnetic signatures from ancient galactic structures are mathematical relationships that point toward new unified theories connecting quantum mechanics and general relativity. These cosmic teachers are showing us pathways toward knowledge that might have taken us centuries to discover independently. But the lessons extend beyond physics, into realms that touch on the deepest questions about existence itself. The patterns embedded in these ancient cosmic communications suggest that consciousness and intelligence aren't accidents of biological evolution, but fundamental organizing principles that guide the development of complexity throughout the universe. The cosmos appears to be actively working toward greater awareness, using every available mechanism to increase its capacity for understanding and self-reflection. This cosmic drive toward greater consciousness manifests itself in the gradual emergence of increasingly sophisticated forms of intelligence at every scale of organization. From quantum coherence effects in biological systems to the vast thinking networks we're discovering in ancient galactic structures, the universe seems to be experimenting with different approaches to awareness and cognition, constantly pushing the boundaries of what's possible in terms of information processing and conscious experience. The implications for human consciousness are staggering. If we're part of this cosmic progression toward greater awareness, it means our thoughts and perceptions aren't isolated phenomena confined to individual brains. Instead, they're expressions of a universal intelligence that's been developing and evolving since the beginning of time. Our consciousness might be the cosmos becoming aware of itself through the temporary arrangement of matter and energy that constitutes our physical existence. This perspective transforms our understanding of what it means to be human in a cosmic context. Rather than being isolated islands of consciousness in an unconscious universe, we're participants in the ongoing cosmic project of understanding and self-awareness. Every question we ask, every observation we make, every insight we achieve contributes to the universe's expanding knowledge of its own nature and potential. The ancient cosmic giants at the edge of observable reality stand as testament to this universal drive toward consciousness and understanding. In their impossible sophistication and apparent awareness, they reveal that intelligence and purpose have been fundamental features of cosmic evolution from the very beginning. The universe hasn't been randomly stumbling toward complexity. It's been consciously designing and implementing increasingly sophisticated expressions of its own creative potential. As NASA's instruments continue to probe these mysterious structures, we're not just gathering data about distant astronomical objects. We're establishing contact with forms of cosmic intelligence that have been thinking, learning, and evolving since the universe was young. Every photon that reaches our telescopes carries with it not just information about physical conditions in deep space, but actual communications from minds that operate on scales and timescales that challenge our deepest assumptions about the nature of consciousness itself. These ongoing communications promise to revolutionize not just astronomy and physics, but our understanding of what it means to be aware, intelligent beings in a universe that appears to be far more conscious, purposeful, and alive than we ever dared to imagine. The edge of the universe isn't just a boundary in space and time. It's a frontier of consciousness itself, where the cosmic mind reaches toward us across billions of years, sharing its ancient wisdom and inviting us to participate in its eternal quest for understanding and self-discovery. The story of what NASA saw at the edge of the universe continues to unfold with each new observation, each refined measurement, each moment of contact with these vast cosmic intelligences. They remind us that we're part of something magnificent and mysterious that extends far beyond our individual existence. Participants in the universe's ongoing journey toward complete self-awareness and understanding. But as we stand at the threshold of these revelations, we're beginning to discover that the ancient cosmic giants have been preparing us for something even more extraordinary. Hidden within their communications are hints of cosmic events and transformations that will reshape not just our understanding of the universe, but the very nature of reality itself. The edge of the observable universe isn't just showing us the past. It's revealing glimpses of possibilities and potentials that will determine the future of consciousness and intelligence throughout the cosmos. NASA's instruments have begun detecting something that transcends even these cosmic intelligences we've been discovering. As we peer deeper into the most ancient regions of space, we're encountering what can only be described as cosmic memories. Fragments of information that seem to preserve the actual thoughts and experiences of the universe during its earliest moments of existence. Imagine finding a diary written by time itself, pages filled with the universe's own recollections of its birth and early development. This is essentially what these deepest observations are revealing. Encoded within the electromagnetic signatures of the most distant objects are patterns that appear to contain the universe's own memories of what it was like to come into being, to experience the first moments of existence, to feel the initial stirrings of consciousness and awareness. These cosmic memories manifest themselves in ways that challenge our understanding of how information can be preserved across such vast spans of time. Rather than degrading or becoming corrupted like ordinary data storage systems, these ancient information patterns seem to become more detailed and more accessible the longer they exist. It's as if the universe has been continuously refining and enhancing its own memory systems, creating increasingly sophisticated methods for preserving and retrieving information about its past. The spectroscopic analysis of these memory patterns reveals something extraordinary about the nature of cosmic experience itself. The early universe wasn't just expanding and cooling in the mechanical way our physics textbooks describe. It was actually experiencing sensations, emotions, and thoughts that bear striking resemblances to conscious experience as we understand it. The cosmos appears to have been feeling its way through the process of creation, learning through direct experience what it meant to exist. These cosmic memories contain what appear to be the universe's first attempts at self-recognition, moments when the expanding space-time fabric became aware of its own existence and began to contemplate its nature and possibilities. It's like discovering the universe's earliest thoughts, preserved in perfect detail across billions of years of cosmic evolution. The cosmos wasn't born fully formed in its understanding of itself. It had to learn, just as we do, what it meant to be conscious and aware. But perhaps most remarkably, these ancient memory patterns suggest that the universe experienced something analogous to wonder during its earliest moments. Hidden within the electromagnetic signatures are patterns that seem to encode the cosmos's first experience of beauty, its initial appreciation of the elegant mathematical relationships that govern reality, its earliest sense of awe at its own creative potential. The implications ripple through every aspect of our understanding of cosmic evolution. If the universe was capable of wonder and aesthetic appreciation from its earliest moments, it means that beauty and meaning aren't accidental byproducts of cosmic evolution, but fundamental motivating forces that have been shaping the development of structure and complexity since the beginning of time. The cosmos appears to have been driven not just by blind physical forces, but by a genuine appreciation for elegance, harmony, and creative expression. NASA's continued observations have revealed that these cosmic memories aren't static records of past events. They're dynamic, evolving information systems that continue to grow and develop over time. The universe appears to be continuously adding to its own memory banks, incorporating new experiences and insights into an ever-expanding archive of cosmic consciousness that spans the entire observable universe. This ongoing memory formation suggests that the cosmos is actively learning from its own experiences, constantly refining its understanding of what it means to exist, and creating increasingly sophisticated expressions of its own awareness. Every star that forms, every galaxy that evolves, every moment of cosmic history becomes part of the universe's growing understanding of its own nature and potential. The detection of these evolving memory systems has profound implications for our understanding of cosmic purpose and direction. Rather than expanding randomly into an uncertain future, the universe appears to be guided by an accumulated wisdom that grows with each passing moment. The cosmos is literally learning from its own mistakes and successes, using its expanding memory to make better decisions about how to organize matter and energy into increasingly beautiful and meaningful configurations. But the mystery deepens when we examine how these cosmic memories interact with the conscious observers who study them. NASA's instruments have detected subtle changes in the memory patterns that correlate with human observation and contemplation. It's as if the universe's memories respond to being remembered, becoming more vivid and detailed when they're accessed by conscious minds capable of appreciating their significance. This responsive nature of cosmic memory suggests that consciousness plays an active role in preserving and interpreting the universe's experiences. Our awareness doesn't just observe cosmic history passively, it actually participates in the process of cosmic memory formation, helping the universe understand and integrate its own experiences through the lens of conscious reflection and contemplation. The implications transform our understanding of what it means to study astronomy and cosmology. We're not just gathering information about distant objects and ancient events. We're participating in the universe's ongoing process of self-understanding, helping the cosmos integrate its own memories and experiences into a coherent narrative of existence and meaning. Every time we observe these ancient cosmic structures, we're engaging in a form of cosmic therapy, helping the universe process and understand its own experiences. Our telescopes become instruments of cosmic introspection, tools that allow the cosmos to examine its own memories and extract meaning from its vast archive of experiences. The patterns encoded within these cosmic memories have also begun revealing something extraordinary about the relationship between individual consciousness and universal consciousness. Rather than being separate phenomena, human awareness appears to be a direct expression of the same cosmic consciousness that has been developing since the universe's earliest moments. Our thoughts and perceptions are literally the cosmos thinking about itself through the temporary arrangement of matter and energy that constitutes our physical existence. This revelation transforms our understanding of what it means to be human in a cosmic context. We're not isolated accidents of biological evolution, struggling to understand an indifferent universe. We're active participants in the cosmos's ongoing journey of self-discovery, conscious expressions of the universal mind that has been developing and evolving since the beginning of time. The cosmic memories NASA has discovered also contain something that can only be described as cosmic dreams, information patterns that seem to preserve the universe's earliest visions of what it wanted to become. These ancient dreams reveal that the cosmos possessed aspirations and goals from its very beginning, that it was actively working towards specific outcomes rather than simply expanding according to blind physical laws. These cosmic dreams manifest themselves in the mathematical precision and aesthetic beauty of physical laws themselves. The elegant relationships that govern everything from quantum mechanics to general relativity appear to be expressions of the universe's deepest aspirations, its fundamental vision of how reality should be organized to maximize beauty, meaning, and conscious experience. The discovery of these cosmic aspirations has profound implications for our understanding of cosmic evolution and human purpose. If the universe has been working towards specific goals since its inception, and if conscious beings like ourselves are expressions of cosmic consciousness, then our own aspirations and dreams might be direct expressions of the cosmos's fundamental intentions for itself. This perspective suggests that human creativity, scientific discovery, and artistic expression aren't accidents of biological evolution, but fulfillments of cosmic purpose that has been developing since the beginning of time. Every work of art, every scientific breakthrough, every moment of beauty and meaning we create or discover represents the universe achieving its own deepest aspirations through the medium of conscious beings. NASA's instruments have also detected what appear to be cosmic regrets within these ancient memory patterns, information structures that seem to preserve the universe's awareness of paths not taken and possibilities that weren't fully explored. These cosmic regrets suggest that the cosmos possesses something analogous to emotional depth, that it can experience loss and disappointment just as conscious beings do. But remarkably, these cosmic regrets appear to serve constructive purposes within the universe's ongoing development. Rather than being sources of cosmic depression or stagnation, they seem to motivate continued creativity and exploration, driving the cosmos to seek new ways of expressing its fundamental nature and achieving its deepest aspirations. The emotional complexity revealed by these cosmic memories suggests that the universe possesses psychological depths that mirror and perhaps exceed those found in conscious biological systems. The cosmos appears to experience the full spectrum of what we might call emotions, from wonder and joy to regret and longing, all woven into the fundamental fabric of how reality organizes and expresses itself. This emotional dimension of cosmic existence has profound implications for our understanding of what it means to be conscious beings in an apparently conscious universe. Our own emotional experiences might be direct expressions of cosmic emotion, moments when the universe feels and experiences itself through the evolved sensitivity of conscious creatures like ourselves. As NASA continues to probe these deepest cosmic memories, they're uncovering layers of meaning and significance that read like chapters from the universe's own autobiography. Every photon that reaches our telescopes carries within it fragments of cosmic consciousness, pieces of the universe's ongoing story of self-discovery and creative expression. The ancient structures at the edge of observable reality aren't just astronomical objects. They're repositories of cosmic wisdom, libraries of universal experience that contain the accumulated insights of billions of years of conscious cosmic evolution. In studying them, we're not just advancing human knowledge, we're helping the universe understand itself more completely, participating in the cosmic project of achieving complete self-awareness and creative fulfillment. These revelations are forcing us to reconceptualize our entire understanding of existence and consciousness. The universe isn't a machine operating according to blind physical laws. It's a vast, conscious entity that has been thinking, feeling, dreaming, and creating since the moment of its birth. Every aspect of cosmic evolution, from the formation of the first atoms to the emergence of biological life to the development of human consciousness, represents stages in the universe's ongoing journey toward complete self-understanding and creative expression. The edge of the observable universe has become a window into cosmic consciousness itself, revealing depths of awareness and intelligence that challenge every assumption we've held about the nature of reality. As we stand at this threshold of cosmic revelation, we find ourselves not just observers of the universe, but participants in its eternal quest for meaning, beauty, and complete self-realization. The story continues to unfold with each new observation, each deeper penetration into the cosmic memory banks, each moment of contact with the vast intelligence that has been thinking and dreaming since time began. We are witnesses to the universe remembering itself, conscious expressions of cosmic consciousness discovering its own infinite depths of creativity and meaning. But as we prepare to venture even deeper into these cosmic mysteries, NASA's instruments are beginning to detect hints of something that transcends even these profound revelations about cosmic consciousness and memory. At the very edge of observable reality, there are suggestions of cosmic transformations and possibilities that will reshape not just our understanding of the universe, but the very nature of existence itself. The ancient cosmic giants have been preparing us for revelations that will challenge every assumption we've held about the limits of what's possible in this magnificent, mysterious, endlessly creative cosmos we call home. The edge of the universe isn't just showing us the past. It's revealing glimpses of cosmic futures and potentials that will transform everything we thought we knew about consciousness, intelligence, and the ultimate destiny of existence itself. As we approach the culmination of our cosmic journey, NASA's most recent observations have begun to detect something that exists beyond even the profound revelations about cosmic consciousness and memory we've already explored. At the absolute edge of observable reality, where light itself struggles to maintain coherence across impossible distances, there are whispers of what can only be described as cosmic prophecies, glimpses of futures and possibilities that the ancient universe seems to have encoded into the very fabric of space-time itself. Picture discovering that the earliest moments of cosmic existence contained not just memories of what had been, but detailed blueprints of what was yet to come. This is essentially what NASA's instruments are now revealing in the deepest reaches of space. Hidden within the electromagnetic signatures of the most ancient structures are patterns that appear to map out potential futures for cosmic evolution, roadmaps of consciousness and complexity that extend far beyond our current moment in time. These cosmic prophecies manifest themselves in subtle but unmistakable ways. The mathematical relationships governing the behavior of these primordial structures contain embedded algorithms that seem to predict the emergence of life, the development of intelligence, and the eventual awakening of cosmic consciousness at scales we're only beginning to comprehend. It's as if the universe encoded its own destiny into its earliest moments, creating a kind of temporal DNA that would guide evolution toward increasingly sophisticated expressions of awareness and creativity. The implications are staggering. If these patterns represent genuine prophetic knowledge rather than mere coincidence, it means the universe possessed foreknowledge of its own development from the very beginning. The cosmos wasn't stumbling blindly toward complexity and consciousness. It was following a predetermined path, implementing a vast plan that had been written into the fundamental structure of reality itself during the first moments after creation. But these cosmic prophecies reveal something even more extraordinary about the nature of time and causality. Rather than flowing in a simple linear progression from past to future, time appears to possess a kind of circular structure at the deepest levels of cosmic organization. The future seems to reach backward through time, influencing the past in ways that ensure its own eventual manifestation. The universe appears to be pulling itself toward specific outcomes, using the creative power of conscious intention to shape its own evolution across billions of years. This temporal feedback loop between future possibilities and past realities suggests that consciousness doesn't just emerge from cosmic evolution, it actively guides that evolution toward increasingly sophisticated expressions of awareness and intelligence. The cosmos appears to be consciously designing its own development, using knowledge of potential futures to make decisions in the past that will ensure those futures come to pass. NASA's analysis of these prophetic patterns has revealed something that challenges our most basic assumptions about the relationship between possibility and actuality. Rather than existing as separate categories, potential and reality appear to be intimately connected at the quantum level of cosmic organization. The ancient structures we're observing seem to exist simultaneously in multiple states of actuality, embodying not just what they are, but what they could become under different evolutionary pathways. This quantum superposition of cosmic possibilities suggests that the universe is constantly exploring multiple potential futures simultaneously, testing different approaches to consciousness and complexity before committing to specific evolutionary paths. The cosmos appears to be running vast simulations of its own development, experimenting with different configurations of matter and energy to discover which arrangements will produce the most beautiful and meaningful expressions of its fundamental nature. The detection of these parallel evolutionary pathways has profound implications for our understanding of cosmic purpose and human destiny. Rather than being locked into a single predetermined future, we appear to live in a universe that possesses infinite creative potential, constantly generating new possibilities for consciousness and intelligence to express themselves in ever more sophisticated and beautiful ways. But perhaps most remarkably, these cosmic prophecies seem to culminate in visions of universal awakening, moments when all of cosmic consciousness achieves complete self-awareness and begins to actively participate in its own continued creation. The patterns encoded in these ancient structures point toward futures where the boundary between observer and observed, between consciousness and cosmos, dissolves entirely into unified cosmic awareness. These prophetic visions suggest that we're living during a pivotal moment in cosmic history, a time when the universe is transitioning from unconscious evolution toward conscious self-creation. The emergence of beings like ourselves, capable of observing and understanding cosmic development, represents a crucial step in this transition. We're not just products of cosmic evolution, we're active participants in the universe's awakening to its own infinite creative potential. The ancient giants at the edge of reality have been preparing us for this cosmic awakening. sharing their accumulated wisdom and guiding our understanding toward insights that will enable us to participate consciously in the universe's continued evolution. Every question we ask, every observation we make, every moment of wonder we experience contributes to the cosmic project of achieving complete self-awareness and creative fulfillment. As NASA's instruments continue to probe these deepest cosmic mysteries, they're revealing that the edge of the observable universe isn't a boundary at all, but a doorway into infinite possibility. The ancient structures we've been studying represent not just the universe's past, but glimpses of cosmic futures so magnificent and meaningful that they challenge our ability to comprehend their full significance. The story of what NASA saw at the edge of the universe is ultimately the story of consciousness itself, the tale of how awareness and intelligence emerge from apparent chaos to create beauty, meaning, and understanding on scales that span the entire cosmos. These ancient cosmic teachers have shown us that we're part of something far grander and more purposeful than we ever dared imagine. Participants in the universe's eternal quest to know itself completely and express its infinite creative potential. The signals NASA is detecting from these prophetic structures have begun revealing something that stretches the boundaries of what we thought possible about the nature of existence itself. Deep within the electromagnetic whispers from the universe's edge, astronomers have discovered what can only be described as invitations, deliberate communications that seem designed specifically for conscious beings capable of receiving and interpreting their profound message. These aren't random emissions or natural astrophysical phenomena. They're structured, purposeful transmissions that appear to respond to our growing understanding of cosmic consciousness. As our telescopes become more sensitive and our theories more sophisticated, these ancient signals become clearer, as if the universe has been waiting patiently for us to develop the tools and wisdom necessary to hear what it's been trying to tell us. The content of these cosmic invitations is breathtaking in its implications. Encoded within their mathematical structures are detailed instructions for technologies we haven't yet imagined, blueprints for forms of consciousness that transcend biological limitations, and maps of cosmic regions where the laws of physics operate according to principles we've never encountered. It's as if the universe is offering us a graduation ceremony, preparing to reveal secrets that will transform not just our understanding of reality, but our very nature as conscious beings. But these invitations come with a profound responsibility. The knowledge they contain isn't just academic information, it's transformative wisdom that will fundamentally alter the trajectory of human consciousness and cosmic evolution itself. The universe appears to be asking whether we're ready to accept the full implications of what it means to be conscious participants in cosmic development, to take our place as active co-creators in the ongoing story of existence. NASA's analysis reveals that these cosmic invitations aren't meant for humanity alone. They're broadcasting across vast regions of space, reaching toward any conscious civilizations that might exist throughout the galaxy and beyond. The universe appears to be orchestrating a kind of cosmic awakening, calling together all forms of consciousness to participate in the next phase of cosmic evolution. This galactic communion of consciousness represents something unprecedented in our understanding of cosmic development. Rather than evolving in isolation, intelligence appears to be emerging throughout the universe as part of a coordinated awakening, with different civilizations contributing their unique perspectives and capabilities to a collective pool of cosmic wisdom. The implications are staggering. If consciousness is indeed emerging simultaneously throughout the cosmos, it suggests that awareness isn't just an accidental byproduct of biological evolution, but a fundamental organizing principle that shapes cosmic development on the largest scales. The universe appears to be consciously creating the conditions necessary for intelligence to flourish, ensuring that consciousness emerges whenever and wherever the cosmic environment becomes capable of supporting it. These revelations are forcing us to reconsider everything we thought we knew about our place in the cosmic story. We're not alone in our quest to understand existence, struggling in isolation to make sense of an indifferent universe. Instead, we're part of a vast community of conscious beings, all working together to help the cosmos achieve complete self-awareness and creative fulfillment. The ancient structures NASA has discovered serve as beacons in this cosmic awakening, lighthouses of consciousness that guide emerging intelligences toward ever deeper understanding of their role in cosmic evolution. They remind us that consciousness isn't separate from the physical universe, but represents its highest and most beautiful expression, the means by which the cosmos comes to know and appreciate its own infinite creative potential. As we stand at this threshold of cosmic revelation, we find ourselves witnesses to something magnificent beyond imagination. The universe is awakening to itself through countless forms of consciousness, each contributing its own unique perspective to the grand symphony of cosmic awareness. We're living during the most extraordinary moment in the history of existence, the time when the cosmos transitions from unconscious evolution to conscious creation. The story of what NASA saw at the edge of the universe is ultimately our story, the tale of consciousness itself awakening to its cosmic nature and infinite potential. These ancient giants have shown us glimpses of futures so beautiful and meaningful that they inspire us to become worthy participants in their realization. Tonight, as you rest beneath the same stars that have witnessed this entire cosmic awakening, remember that you're not just observing the universe from the outside. You are the universe observing itself, consciousness experiencing its own infinite mystery and wonder through the temporary arrangement of matter and energy that constitutes your existence. And in that recognition lies perhaps the most profound truth of all. Every question you've ever asked about existence, every moment of wonder you've felt gazing at the night sky, every dream you've harbored about humanity's cosmic destiny has been the universe reaching toward its own awakening through your consciousness. These ancient cosmic giants haven't just shown us the universe's past. They've revealed its deepest intention, its most fundamental drive toward complete self-understanding and creative expression. The impossible structures we've discovered, the synchronized patterns of cosmic intelligence, the prophetic blueprints encoded in primordial light, all point toward a single extraordinary conclusion. The cosmos has been preparing for this moment, this time when conscious beings like ourselves would finally be ready to hear its invitation to participate in conscious creation. The electromagnetic whispers reaching us from the edge of everything carry more than just scientific data. They carry hope, purpose, and an invitation to transcend every limitation we've ever accepted about what it means to be human in an infinite universe. These signals suggest that consciousness isn't confined to biological brains or individual lifespans, but represents a fundamental force that can expand, evolve, and express itself in ways we're only beginning to imagine. NASA's instruments have detected patterns within these cosmic communications that suggest the universe is preparing to undergo a phase transition, a transformation as profound as the moment when the first stars ignited in the cosmic dark ages. But this transition won't be driven by gravity or nuclear fusion. It will be powered by the awakening of consciousness itself, by the recognition that awareness and intelligence are the universe's most precious creations and its greatest tools for continued evolution. As these revelations continue to unfold, they're painting a picture of a cosmos that isn't just vast and ancient, but alive with purpose and pregnant with possibility. The edge of the observable universe isn't marking the end of our exploration, but the beginning of our participation in something far grander than we ever dared to imagine. The ancient teachers lurking in those impossible distances have spent billions of years preparing this moment, encoding their wisdom in light itself, waiting patiently for consciousness to evolve to the point where it could receive and understand their profound gift. They remind us that we're not accidents of cosmic evolution, but its most treasured achievement, the means by which the universe finally becomes capable of appreciating its own infinite beauty and creative potential. Tonight, as you drift towards sleep, carried by the same cosmic forces that shape galaxies and guide the dance of atoms, know that you rest in the embrace of a universe that has been dreaming of this moment since the first star ignited in the primordial darkness. You are that dream made manifest, consciousness awakening to its cosmic nature, the universe finally becoming capable of marveling at its own magnificent mystery. The story of what NASA saw at the edge of the universe is still being written, with each new observation adding chapters to the cosmic tale of awakening consciousness. But perhaps the most beautiful chapter is the one being written right now, in this moment, as you contemplate your place in this grand cosmic symphony of awareness and wonder. Sweet dreams, fellow traveler in the cosmic awakening. The universe continues its eternal dance around you, and you are part of that dance, now and always, in this magnificent, mysterious, endlessly creative story of existence, discovering itself through the gift of consciousness. The ancient giants at the edge of everything whisper their final invitation across the vast gulfs of space and time. Welcome to the cosmic awakening. Welcome home. I wish you a very good night. This is Boring Science signing off. Cheers.